Assalamualaikum and good morning to the doctor and friends. I am Maidatul Mashita binti Muhammad Tamizi from Group 2. Today, I would like to present about capacitive transducers. What is capacitive transducers? The capacitive transducer is used for measuring the displacement, pressure and other physical quantities. It is a passive transducer, that means it requires external power for operation. The capacitive transducer works on the principle of variable capacitance. The capacitance of the capacitive transducer changes because of many reasons like overlapping of plates, change in distance between the plates and dielectric constant. The capacitive transducer uses the electrical quantity of capacitance for converting the mechanical movement into an electrical signal. The input quantity causes the change of the capacitance, which is directly measured by the capacitive transducer. Shown in the figure below, a capacitive transducer has a static plate and a deflected flexible diaphragm with a dielectric in between. When a force is exerted to the outer side of the diaphragm, the distance between the diaphragm and the static plate changes. This produces a capacitance which is measured using an alternating current bridge or a tank circuit. A tank circuit is more preferred because it produces a change in frequency according to the change in capacitance. This value of frequency will be corresponding to the displacement or force given to the principle of operation. The capacitive transducers works on the familiar capacitance equation of parallel plate capacitor, which is given by the capacitance of the capacitor equal to the absolute permittivity times the relative permittivity times the area of the plates divided by the distance between the plates. Capacitive transducer using change in area of plates. Formula shown in this slide is the formula of capacitance. Capacitance is directly proportional to the area of the plate. Parallel plate capacitor. For parallel plate capacitor, the capacitance is permittivity of dielectric times the area of plates divided by the distance between the plates. Or we also can use permittivity of dielectric times length of overlapping part of plates times width of overlapping part of plates divided by the distance between the plates. So, let's move to the sensitivity. What is sensitivity? The sensitivity is constant and therefore is a linear relationship between capacitance and displacement sensitivity for a fractional change in capacitance equal to S prime. This type of capacitive transducer is suitable for linear displacement measurements ranging from 1 mm to 10 mm. The accuracy is high as 0.005%. Cylindrical plate capacitor. For the cylindrical capacitor, the capacitor is C equal to 2 pi times permittivity times length of overlapping part of cylinders divided by log E bracket D2 is inner diameter of the outer cylindrical electrode divided by D1 outer diameter of the inner cylindrical electrode close bracket. For the last answer, the unit should be in farad. Its sensitivity is also connected and the linear relationship between capacitance and displacement is linear. The principle of change in capacitance with change in the area can be employed for the measurement of angular displacement. The capacitance is maximum when the two plates completely overlap each other. The maximum value of capacitance equal to C max. This can be used for a maximum angular displacement of 180 and the variation of the capacitance with the angular displacement is linear. Capacitive transducer using change in area of plates. One capacitor is fixed and the displacement to be measured is applied to the other plate which is movable. The capacitance C varies inversely as the distance D between the plate changes and the response of this transducer is not linear. Application of capacitive transducer. A capacitive transducer can be used for the measurement of force and pressure. The force and pressure to be measured are first converted to displacement, which causes a change of capacitance. Capacitive transducers can be used for the measurement of both linear and angular displacement. Capacitive transducers are commonly used in conjunction with mechanical modifiers for the measurement of volume, density, liquid level, weight, and others. Capacitive transducers are used for the measurement of humidity in gases since the dielectric constant of gases change with the change in humidity, thereby producing a change in capacitance. Advantages of capacitive transducer. The sensitivity of capacitive transducer is high. The capacitive transducer is useful for small systems. It has good frequency response. It requires more power to operate. The loading effect is less due to high input impedance. Disadvantages of capacitive transducer. The capacitive transducers are temperature sensitive. It gives nonlinear behavior. The output impedance depends upon the frequency used. The capacitor may get changed by dust, particle, and moisture, which produce error. That's all from us. Thank you.